today we are honored to have Professor Yeron Ok to give a guest talk to share about his exciting research and also some interesting topic of our students. Okay, so now it's your stage, Professor Yeron Ok.
Very nice, thank you. I'm very honored to be here and very thanks for inviting me. I mean, it's really nice that I can talk to all of you and I can actually see some of you as well. So that's really nice. I hope the microphone is a bit better now.
Yeah, it's okay. Yeah.
Okay, good. Then I'll reset my timer here because I've prepared a lecture of about an hour or so, and we also have 10 minutes for questions, so it's like somewhere between 1 hour and 1 hour and 10 minutes. Yeah, I'll be talking about interactive visualizations for explainable AI research and research practices. So that includes two parts. You see that I'll talk about my research for a bit, but I also want to talk about how I use visualizations in my research practices. But before diving into the content, I was thinking maybe it's nice to show a bit of where I am and what I'm doing. So as you can see here in my background, it's pretty dark. That is not because I'm closed off, but it's because it's very early here. I'm actually at the moment in Belgium, in a city called Leuven. It's a city near the capital, Brussels. And it's here 7:30, so it's extremely early for me, but I'm super excited to get up early for you. Apart from Leuven, I also live and work in Utrecht, which is officially a different country. It's the Netherlands, but it's not that far. I mean, it's 3 hours by train. So in terms of what you're used to in China, probably that's very close. I also wanted to introduce this kind of joke because people never really know how to pronounce my name. I have like a horrible name, internationally speaking, because it's very hard to pronounce. So in Dutch, that's my mother tongue. It would be Jeroen Oge. That's extremely hard. So I typically pronounce it in the English way, which is something like Jeroen Oge. So something like Professor Yin just also used. And this is also how I introduce myself. But so now you're used to the Dutch sound of Jeroen Oge, which is a bit different, right? I also wanted to introduce you to this character. This is the Viz character. He will be joining us through the presentation, and probably you're wondering why I'm choosing a fish, because that's very weird. But actually, it's very simple. I'll be talking about visualizations, and we typically abbreviate this to Viz. And actually, this is also a Dutch word because vis means fish. So for me, it's always very funny when I talk about vis, because then I just see a fish swimming in my head. And so this is why this fish will accompany us in the coming hour. I also wanted to give you a very brief glimpse of my personal background, because yeah, probably you're just wondering why I am the person talking to you and not someone else. There's so many nice people doing all this interesting research with visualizations. So I'll just give you my professional update here. I have a master in fundamental mathematics. I have a master in applied informatics. Then I came into touch with human-computer interaction and visualizations. It was really nice. So I decided to pursue a PhD, which I did at KU Leuven, which is the biggest university in Belgium. That's also why I still live in Leuven. And then after my PhD, which I finished last year, I immediately became assistant professor in Utrecht University, which is in the Netherlands, as I told you. And yeah, probably you're wondering, like, what does this have to do with visualizations? Well, the point is that during my PhD and also currently and in the coming years, I have and will be working on human-centered explainable AI with visualizations. So you already see where visualizations are coming in. But maybe some of you are not really familiar with what human-centered explainable AI really means. And I mean, this whole talk is going to be focused on visualizations, but maybe it's also nice to have a bit of a better understanding of this human-centered explainable AI, so that you can better understand the context of my research. So I just want to give you like a couple of slides about this topic and what I mean with it. and then I'll go and cover the visualization parts. So probably you all know AI is everywhere. We've been using it for many things. And I always compare AI models to coffee machines. It's like you put something in the beans and then something happens and then something comes out and that is the output. So the idea here is that we're putting in all these coffee beans and then there's this magic process and then all of a sudden there's something we can use. But it's not always clear what this process looks like and what is actually happening inside this coffee machine. And that is why we call these models very often black boxes. A black box because you cannot see what is happening on the inside. There's some kind of magic happening, basically. And so the question here is there a way to open this black box? Is there a way to get some insight in what is going on when these AI models are making decisions? And there's actually a lot of potential solutions to solve this problem. There is different explanation types. And so this is where the word explanation or explainability comes in. There is, for example, local explanations where we'll try to look at, okay, if we put something in and then we try to change a bit of the input, how is the output going to change as well? So this is a local explanation. One example here is feature relevance. That means, for example, if you have input with different features, let's say we're talking about houses and we're predicting the price of a house when we're selling it, then one of the features can be location, it can be how big the house is, it can be the previous owner, whatever. So feature relevance will say to each of these features how important they are for the outcome. And then there's other types like you can give an explanation by giving an example. You can also simplify the whole model. Very often models are very complex, but then you can simplify them into a simpler model. For example, if we have a neural network, then we can simplify it to a decision tree. And decision tree is easier. It's not the same model anymore, but it's maybe an approximation. And these visualizations can be represented in different ways. You can represent them as text, or you can represent them in a visual way. And so obviously this is what we will be talking about. What kind of visualizations can we use to explain a specific part of an AI model? And as you noticed while I was talking, explanations don't mean that we will try to explain all the technicalities and all the mathematics in the AI model. We'll actually be focusing on like a small part and trying to see how it justifies the AI outcome, for example, by this feature relevance, like a specific insight that tries to make us understand better what is going on, but not maybe get a full picture of the full model and all its intricacies. But this sounds very easy, but it's actually not, because there's questions on what type of explanation we want to use. This depends on the target audience, so the people, and there's also kind of context that we are working in, and there's an application domain, there's background knowledge of audiences, and depending on all these factors, we need to make different decisions. And this is where the human-centered part comes in. So when we're talking about human-centered explainable AI, what we are actually acknowledging is that if there's different people and different application contexts, those need different explainability solutions. For example, if we're explaining something to an AI expert, then of course we'll have to talk about all the algorithmic technicalities and mathematics. But if we're talking to, let's say, my sister or my grandmother, they don't have an AI background at all. So then, yeah, of course, we're not going to talk about mathematics. Maybe we're going to talk about a more simple insights. And so in this context, my personal goal, and of course also the goal of many other colleagues, is that we are trying to design visual explanations, and then we are trying to evaluate how these explanations affect people's behavior. And people's behavior can be the trust that they have in model outcomes, their understanding of how this model is actually working. Can also be other things that are not related to the AI itself. Can also be how motivated they are to do a specific task, also how good they are at performing the task, etc. So it can be, a lot broader than just this focus on AI models. So this is what I mean with human-centered explainable AI. So it's just a bit of a background for you. But now, of course, I want to talk about visualizations because I'm very excited about this medium. I think it's a very nice combination of scientific insights, design, and a bit of art actually sometimes. So I've prepared 3 parts. First, I'll be talking about complex visual dashboards. Then I'll be talking about simple visualizations. And then finally, I will also give a bit more hands-on on visualizations in reports, scientific reports, that is. And for this, I will be using the nested model by Tamara Munzner. And I think that you are familiar with this model. There's 4 layers in this model, where we first always focus on the domain situation. We're asking about what is the domain, what are the target audiences here, what are the actual questions that people have. For example, the domain could be healthcare, and then the target audience is doctors. And then on the second layer, we are trying to abstract the tasks and the data that we have. So for example, maybe people want to analyze something, maybe they want to search in a database, maybe they want to query their database. And then on the third layer, there's a visual encoding. So obviously, when we have a specific audience and we have a specific task, we want an data, then we also need to visually encode this data. And typically, interaction is also something that we want to integrate with our visualization because we get more insights that way. And then in the model, there's also a fourth component, the fourth level of algorithms, where we're focusing more on how can we optimize the algorithm such that the visualization performs well. I will not typically cover this part because actually I'm more interested in the first 3 layers. Given my human-computer interaction background, we typically ask ourselves, who are we designing for? What is the kind of context here? What is the task that we want to do? And then how should this visualization look like? And then we typically iterate a couple of times over this visualization and then the kind of interactions that we want to support. So for all the examples that I will be giving you throughout the talk, I will always introduce a bit of the background with these 3 layers, basically, to give you a bit of understanding of what we're talking about. And then you just see the visualization, and I tell you a bit about the research that I did. But very brief, because actually I will mainly focus on the visualizations here, because that is what you are interested in. So let's start with the first part on complex visual dashboards. And there's 3 examples that I want to give you of my previous work. And the first one is about visual analytics in healthcare. So, way back 4 years, 5 years almost ago, when I was starting my PhD, I was interested in visualizations and I was interested in healthcare, but I wasn't really aware of works that showed me, what kind of visualizations actually exist in healthcare and what kind of visual analytics approaches are being used. As you know, visual analytics means that there is some kind of model in the background going on. It can be an AI model, it can also be advanced statistics. But what kind of data analysis techniques and visualizations that were being used in healthcare wasn't really clear for me. So I thought, okay, let's just do a systematic review. That means just, look for papers and see whatever you find and just collect everything and kind of write a summary of all these findings. So the domain here was pretty clear. It was about healthcare. The audience wasn't clear. It could be anyone. I typically divide anyone in 3 groups. There's AI experts, people who know everything about AI. There's domain experts who have a very good understanding of the domain, so healthcare, but they're not necessarily AI experts. So for example, a doctor is of course an expert in the field, but not necessarily in AI. And then there's AI novices, people who don't have a background in healthcare or AI. So for example, that could be the patients in this case. I wanted to see what kind of tasks were being supported. One framework is monitoring, interpreting, and predicting, but I'll come back to that. And then in terms of visualizations, this visual encoding was also open. I mean, I was just looking for anything that existed and then any kind of interactions as well. And I will cover these in a second as well. So basically, I was just looking for all the existing work where, there's some kind of algorithm involved in healthcare. These algorithms typically need some kind of explainability. And then how is this explainability established? Well, that would be then the visual analytics that would give us insights in the data or the model. And maybe that's like the dotted line over there. Also allow us to have some control over the algorithm. So that is the context of this work. And in the end, I found 4 categories of ways where interactive visualizations can give insights in models. So there is visualization. We can just visualize data, and then based on the visualization, we immediately get some insights. We also have interaction, where it's actually the interaction that will give us the insights. So just visualizing something is not always enough. Sometimes you have to interact with the data to really see different angles of the data and of the model. Then there is also this control that I already mentioned. There is a way in which we can use visualizations to actually control the model in the background through, for example, sliders or maybe the visualization itself. And then finally, there's also direct explanations. That's what I called it, at least at the time, where we are using all these different approaches that I showed you before, like feature importance, or an example by a visualization where we show an example. And so these examples I typically put in the category of direct explanations. So let me give you some examples here. First, visualization. We can visualize a lot of different models in different ways, but typically when we have specific models, we come across similar kind of visualization. So we typically visualize models in a similar way. So for example, if we have a clustering algorithm, as you can see on the left, very often we would also show the underlying data clustered. So you would have all the data points be projected in a plane, and then we would color all the dots according to the category, the group or the cluster that they belong to. So like you have a yellow cluster, you have a purple cluster, etc. Yeah, there's other approaches like similarity measures. There's typical classical statistics like correlations, dimension reductions, data mining, anomaly detections. All of these AI approaches are typically visualized in a specific way, as you can see. Then there is a second category on interaction. There's different ways and taxonomies actually that tell us how you can interact with the visualization. If you're interested in like the details, I mean, you see the taxonomy here, but if you're interested in the details, then you can refer to the paper, and that refers to another paper. So the first one is, for example, abstract and elaborate, which means typically details on demand. This is what the term that you are probably used to. You can hover, for example, and get some more information. You can also filter on the data that you see. For example, here there is something related to brain scans. And by filtering on specific areas in the brain, which are indicated here in blue and in red, you get different insights in what kind of areas are important according to this AI model background. Reconfigure means you can switch stuff from places. You can encode the data in a different way. For example, you can show it as a scatter plot, but maybe you can also show it as a different plot. You can select data. This is what you see here. You can like maybe draw like a lasso around the data points that you find interesting, and then you would get some more information about these data points. Then there's also connect. So there's different parts in a dashboard, for example, that are connected with each other. So this is, for example, very often linked to selection. So you can select a data point in one visualization in the dashboard, and then the rest of the dashboard will automatically update. And then there's also explore here, where you can explore different data points, etc. Then the third category was control. So we wanted to have control over an AI model through our visual dashboards. And actually, there's a whole spectrum of ways in which you can do that. There's approaches that are called semi-interactive, which means you will just have like a screen with a configuration where you can, for example, say, okay, these are my model parameters that I want to use. And then in a different screen, you will see the visualization and then the result of the actual model. So this is what happened in this example. It's very small, but I mean, there was a previous screen where you can tune the model parameters, and then only afterwards you see the visualization here. And then you can go all the way to tight integration, where you actually do this kind of things simultaneously while seeing the visualization or through the visualization even. So for example, when we were making it a bit more integrated, that means, for example, we can put these settings on the same interface as the visualization. Maybe you can even like change the parameters and immediately see the changes in the visualization. So you don't have to push a button like rerun, it just happens automatically. And then there is like the full tight integration, which means that you just have the visualization, and through interacting with the visualization, you're actually manipulating the underlying algorithm, and you immediately see what is changing in the background. For example, this was a study also on brain scans. I don't know why, but they like brain scans a lot apparently in healthcare. And by tweaking like the things that you see here, there's like these little knots and these little lines everywhere. You were actually manipulating the underlying model, and then you immediately see the impacts. So a big range in control. And then finally, there were these direct explanations, which are more centered on algorithms again, like the feature importance that I mentioned before. This was a pretty intricate visualization of how the different features contribute to a model outcome, and then they visualize it in different ways. You could also just visualize the model itself, like immediately. For example, here, this model was trying to predict how specific tissue was behaving. And then there were all these little spikes, and those little spikes were actually visualizing how this model was building this tissue. Again, I will not cover all the details here, but this just gives you a bit of an insight in how you can directly explain model outcomes as well. Partial dependence plot, for example, the first one, is actually also very nice. Like you can change the features immediately with these sliders, and then you would see how the model would change. And the colors also indicate immediately before you actually change it, what the outcome would be. So for example, if you have this slider with blue and red, then blue is one, prediction, and red is a different prediction. So even before you change the feature, you would see how the model would behave. So okay, that was like the fourth category, and was like a big study on all these examples of what you could do to visualize model outcomes. But then, of course, I wanted to know, how can I do this myself? Like what makes sense here? So we were working on a project where we were trying to predict diabetes onset. So yeah, diabetes, of course, and we were trying to predict based on healthcare data, whether someone was at risk of developing diabetes. So the domain was healthcare again. We wanted to focus on healthcare professionals and also on patients, because very often, doctors are using all these dashboards to get insights and have these models that will predict whether someone gets diabetes or not. But then we also have to talk to patients and explain to them what they have to do and why. So yeah, those were our two target audiences. And the task that we wanted to support was, okay, you have one patient, but there's many others. So maybe we want to allow healthcare professionals to compare one patient to other patients, and also propose actions to minimize this risk of getting diabetes. And the encoding I will show you actually right now. I just want to show you this and not cover all the details, but just want to like highlight the specific parts. So at the top section, you would just see the risk visualized, very simple. It's just a donut chart together with the data of a specific patient that you could change if you wanted to. And actually, the only interesting visualization here I find is the density plots that you see here and the bar charts. So again, it's pretty simple because remember, we were also using this dashboard to talk to patients, and patients are typically AI novices, which means they don't have like a background in all the technical parts. So we keep things simple, and we try to just visualize their data in correspondence to that of other patients. So here you would see, for example, a density plot with their own value for blood sugar in this case. And then you would see the distribution of other patients. And you would see, okay, this is green, which means this is actually good. This value seems to not contribute to it will not contribute to having diabetes or getting diabetes. And then other parts would just show the risk over time in a line chart, very simple. These are the actions that we were looking for. So there would be different actions that doctors could click on to see, okay, for example, if you would stop smoking, then you would lower your risk by X%. And then there's also these feature importances that I also mentioned before already in different contexts. How does your blood sugar level contribute to your risk? In this case, it has a negative impact in the sense that your blood sugar seems fine, so it lowers your risk. Okay, so that was for healthcare. Then, yeah, obviously there's many other application domains where you can apply all these ideas. And one of these ideas was agri-food. So agri-food is just like a combination of agriculture and food. And we were also doing a project there during my PhD, where we were trying to come up with a visual dashboard for domain experts. So people who are active in this industry and are actually very well aware of both the domain parts, so like people who are making recipes, let's say, for cookies in factories, and also people who are actually data analysts in these companies. So we wanted to allow them to have a data set of price predictions for different products in different countries. And then we would try to let them compare different countries, different products. I'll show you in a bit what that looked like. And finally, we also wanted to predict these prices and also visualize the uncertainty in these predictions. And the way that we did that was fan charts. I'll show you what that looks like in a second. And then, we would want to allow them to interact with these visualizations by getting details on demand, so more details, filtering because they wanted to compare different countries. And we would wanted to enable and disable visual components here. And I'll show you what that looked like here. So this is what I've been talking about. There was a data set with different products. For example, butter, could be flour, could be anything. And different countries, European countries, because this was a data set from the European Union. For example, Germany and Greece, etc. And then we would visualize just the timeline with the data of the products, and then we would also predict those prices. And then you also see that we visualize the uncertainty. These are these different colored bands, basically, which show the prediction intervals. So the wider interval, the wider the uncertainty as well. So in action, it looked like this. There would be these checkboxes at the bottom that would show the data, the prediction, and then the future uncertainty, and also the past uncertainty. And they could compare different countries, as you can see here, and then just play around with this whole thing. And to evaluate this visualization, we went through all these different cases. First, they saw the past data, then they enabled the next checkbox with the future prediction, then the next checkbox with the future uncertainty, and then finally also the past uncertainty. So first we went through these 4 steps for one country, then we added a different country, and then we went through the same 4 steps again. And we were doing interviews to see how people were actually using this, whether they could understand the visualization, what parts of the visualization and the interaction made them trust these models, etc. So in the end, we found this. There were different topics, basically, that people mentioned, usefulness and needs that they had, model understanding, and then trust. Basically our main finding was that there's both direct and indirect ways to gain trust in the visualization. For example, some people said, oh, I need tailored explanations about this prediction model. I want to understand a bit better what this model looks like. Then they saw this uncertainty, for example. They saw like the fitting line of the model, and then they already understood, oh yeah, okay, this is a nice explanation. I immediately trust the model more because I just see it, that's it. But others were a bit more skeptical, so they actually did like a second step. They used all these components to better understand the model on an algorithmic level. So for example, they would see the shape of this prediction line, for example. And then they would better understand the model and how it would behave after they interacted with it and did all the different comparisons. Some of them, for example, had a need for comparing different things, different products or different countries. And because the dashboard allowed this, they better understood how the model was behaving in different countries. And it was this understanding that allowed them to better calibrate their trusts in the model, because they could see, oh, the model's actually performing well, or yeah, maybe it's performing badly. And actually, in our case, it was performing badly. And therefore, they had less trusts. All right, so this was the first part with all these complex dashboards. And yeah, after every part, I want to give you a bit of time to breathe, maybe reflect a bit. So yeah, I foresaw 5 minutes of questions and basically breathing. So if you have any questions about what I've been talking so far, I'm very happy to answer them right now.
Yeah. Okay, so we have to add questions.
Yes, thank you, Professor August. Thank you for your exciting presentation. And when I first saw your topic, the expandable AI, I thought this would be some kind of we dig into the natural structure of the AI model and see how they connect together. But for now, I think my first thought was wrong. So how would you define the expandable AI? Are we only focused on the outcome of our AI model?
Yeah, that's actually a very good question, because indeed that comes back to what I was saying about what I mean with explainability. When we're talking about the more algorithmic background of a model, so I think what you are alluding to is, really the different components in a model and then how these contribute together to a specific outcome. This is what I would call not explainability, but interpretability. So to interpret a model would be getting insights in the technicalities, getting insights in like the mathematics, basically. When I'm talking about explainability, actually this is broader and typically also simpler, as you also noticed. Typically, it's more focused on how a specific outcome is being computed basically by the model. And then we're not focusing on the whole model and all its components together and how they contribute together, but on just one specific part. So the feature importance, maybe you just change the input, see how it affects the outcome. That is what we call a what-if explanation. And so there's all these different types. There is how explanations, why explanations, what-if explanations, that always just focus on one specific model behavior aspect, basically. And that is because from a human-centered perspective, people typically try to reason about these models in these ways. So they're looking for a specific simple insight instead of trying to understand the full complexity of the model. Because yeah, then basically you have to be or become an AI expert. So maybe for people like you and me, we are data experts, we know a bit about AI, maybe we are looking for all these details, but yeah, think about my grandmother, think about my sister, they don't know anything about AI. So then we typically go for these simpler explanations.
So any other questions? Regarding the first session about healthcare domain visualization.
And then I suggest that we continue to the second part, because actually this was a kind of the boring parts, and now it will become increasingly exciting. So this was a bit of the like theoretical background with some examples, but they still look very complex. And now I wanted to talk about simple visualizations. So now I will not focus on data experts anymore. I will not show you all these complex dashboards anymore, but I'll show you some more simple examples where I'll be talking a bit more about the design aspects, and afterwards in the third part, I will show you some actual, hopefully, takeaways that you can use yourself in reports. So in this part, there will be 4 examples. You see that there is 3 out there. And then there is like a bonus. And I put it there because the bonus is different from the rest of the story, whereas the other three are kind of part of the same story. The story is here about explainable AI still. We have a learning dashboard. So there is a website. I'll be talking about education. There is a website with an e-learning platform. So students can go to this platform and then they can make math exercises. So typically what we have here is there's different students with a different expertise level in mathematics. They go to the platform and this platform will generate or actually compose different exercise series that are tailored to their level. So for example, if there is someone with an expert level in mathematics, so very good, then once they log into the system will say, okay, you're very good at mathematics. Here are some very hard exercises that are well suited for you. And then, here is a series of exercises that match that level. Maybe other people are a bit weaker, they're more like beginners, and then the platform will notice this and then generate a slightly easier series of exercises. So yeah, what is happening in the background here on algorithmic level is related to ELO ratings. Basically, it's just constantly monitoring someone's level by looking at how they perform on exercises. If they do something right, their level goes up, and then the difficulty of the exercise goes down. And based on how these students are actually interacting with the exercises, the system is actually monitoring their level all the time and also generating different series of exercises. So this is kind of the context that we are working in. And so the three first visual explanations are all related to education and teenagers, because this platform was built for high school. So these are teenagers, young children. So that immediately suggests that the visualizations that you will see are very simple because, yeah, when we're talking about teenagers, yeah, basically that's minors or children. Some of them were 11 years old. Then obviously you cannot build this very complex visual dashboard. So in the first study, we wanted to justify these recommendations. So, okay, we are recommending specific exercise series, but then, yeah, why? Why do you get this recommendation and not a different one? And so the task that we wanted to support was, okay, we want to give you a bit of insight in how this model is behaving, because this model was using collaborative filtering. And as you know, that means that it looks at different students and how they perform. And then based on that estimate, it guesses what kind of exercise is suitable for you. So the task that we wanted to support was, yeah, look at the performance of others, the performance that the model is taking into account, that is. And then we would visualize this very easily, but there will be no interaction in this example. So it's, yeah, pretty boring. This is also in Dutch, by the way, but I will translate. I always forget to translate this example. So this is the interface that students saw once they finished an exercise, and they would get a next recommendation. So here on the left, there is a recommendation, 3 exercises, and then this right part here is the explanation that they would see. There's a textual part and there's a visual part. The textual part actually says the same thing. It says, we recommend this exercise because it fits your current level. So that suggests that there's a model looking at level. And then the second sentence says, we expect that, by looking at similar students, we expect that you would need 1 or 2 attempts to solve this exercise. And so this alludes to the collaborative filtering that was happening in the background. And so the visual part here, the third component, would actually show the attempts of these other similar students. So here there's a very simple bar chart, obviously, with the number of attempts that these students needed to solve the recommended exercise. So, okay, exercise 21, we checked at other students, how they performed on this exercise. As you can see, 14, so most students just needed 1 attempt and then they got it right. So that means probably it's a simple exercise and probably you are able to do this as well in 1 or maybe 2 attempts. So yeah, as you see, it's just a bar chart. It's very simple. And maybe you're like, oh, wow, that doesn't look very fascinating. maybe you're right, maybe it's not. But coming up with this design actually takes quite some iterations, because typically we start from something more complex. And then we go talk to young students, and then basically try to see whether they understand the visualization, whether they actually get the insights that they like or that they need. And in this case, just showing data of similar students and how they perform was sufficient for them. You also notice, for example, that we made some design decisions here. For example, the bars have different colors. Actually, that's not very needed. You could make all of these bars gray, and you would see the same data. But actually, with the colors, we first wanted to make the visual appeal higher, because young children preferred seeing colors. But also they suggest that green means at least in European terms, it typically means it's easy, it's good, and red means it's hard or it's bad. So green suggests already that it's easier than red. So if you show this to someone in Belgium, then they would, by looking at the colors, also get like a second kind of understanding of, oh, this big bar, it means less attempts, and so it means easier. So that's why we chose to add some colors here. And then just to give you a bit of background on actually what this visualization or this explanation actually did in terms of trusts. We did an experiment where we compared this interface with an interface where there was no explanation, and also an interface with like a fake explanation, an explanation just saying, oh, we recommend this exercise because our algorithm decided so. Yeah, that doesn't really explain, why this recommendation was being made. It's just like a sentence that, there is some kind of algorithm, but it doesn't explain anything. And so what we did in this experiment is measure the trust that students had, and actually having these visual explanations, so the dashboard that I showed you, increased their initial trusts slightly compared to the other interfaces. So that's interesting. You also see that probably these explanations were not the most important factor. That is because actually students reported very high trust for all interfaces. So maybe it wasn't just the visualization that, bumped their trust dramatically, but it was already pretty high, and it bumped it a little bit more even. So that is the first example of the effect of a visual explanation on the behavior, the trusting behavior in this case, of students. Then we wanted also to explore how people could control an AI model. So we have this recommendation model, and yeah, it's fully automated, of course, but we were thinking, how can we give these students control over this model? Because, if you remember from the healthcare domain, there's many ways to control AI models. And so in this case, we were thinking about how can we do that with our recommendation system, and how can we show them the effects of that control. So we wanted to visualize the changes in mastery after they controlled this model. And we did this with a very simple line chart. Again, it was not interactive, but this is what it looked like on the website, on the platform. It's again in Dutch, but I'll show you a translation immediately after this. So this is how an exercise looked like. They solved something correctly, and then they got this slider to make something easier or harder. They chose something harder, and then afterwards they see this visualization of how their level changed during practice, and then after they controlled the model. So here is the same visualization in English, which is probably a bit easier to follow. Again, it's very simple. This axis just shows the mastery level that they have, ranging from novice to expert. It shows the level that they had before they were practicing. It shows the level after they practiced. And you see that it increased because they had a correct answer. And then afterwards, after the feedback that they give, so after the control with this slider, it goes up even more. And that is because they chose to make it harder. So they went to the right on the slider, which means give me harder exercises still. So actually what this control does is, this system will automatically change my level based on how I perform. but maybe I want to converge faster, for example, to harder exercises, and I can like bump my level upwards so that in the next step, the system gives me the harder exercises faster. So that was the idea. Again, this looks very simple. It's just a line chart, basically, one line. Again, we just used colors for this line. You see how there's a gradient from orange to green to make it a bit more attractive, and also to highlight the change that is being shown here. And again, we just wanted to understand better how is this visual, this visual representation of the control changing the trusting behaviors of students. We again did a very similar experiment as before, an experiment where, they just had recommendations completely automatically. They did not have control. They did not see visualization. There was a second group where they had this slider, the slider that you saw from before, to make something harder, to make something easier. But then they did not see a visualization afterwards. It would just, do the control, and then you get the next recommendation. And then the third group had both the slider and the visualization, the way that you saw it in the short video. And again, once we measured initial trust, we saw that having this visualization actually increased trust, but the control mechanism alone did not. So when we compared the groups, the control group without anything and the control group and the group with control, those two did not differ in terms of trust. But once we added the visualization, it did affect their trust upwards, actually. So by seeing this visualization, students had a better understanding how this model in the background, this recommendation model, was behaving, because they could track their mastery levels, and then they saw, oh yeah, it goes up when I ask it to. When I make something, when I solve an exercise wrong, it goes down. That's what I expect. So they got better insights in the behavior of a model in that way, and therefore trusted it more. But as I told you, like just having the control itself was not sufficient. So it wasn't just the control that bumped their trust. And then in the third example that I want to show you, we were thinking, how can we combine these two ideas a bit better? Because before we just had a visualization. After there was a recommendation. Then we said, okay, we will add a control. But then the visualization was only shown afterwards, right? First there was an interface with a slider, but you only saw the visualization afterwards. And this goes back to what I showed you in healthcare, where we had this whole range of integration. There was semi-interactive integration, which is kind of what we did in the previous example. One interface with a slider control, and then a second interface afterwards with a visualization. And we were thinking, how can we connect it more tightly, like this tight connection that I showed you before with the brain things? How can we give them control and let them immediately see what the effect is going to be? That's why we made a different design. Again, it was the same platform with teenagers, and we wanted to show them the predicted mastery change immediately when they were having this control. And we encoded this in a very similar way, but we put both the control and visualization on the same screen, such that they could interact this time. It wasn't static anymore. They could interact with the slider and immediately see the visualization changes. And this is what it looked like. Again, this is in Dutch, but I mean, you get the point. There's the same slider as before. The only difference here is that the slider is actually choosing the difficulty level. So when they go to the right, they're choosing an exercise that is very hard. When they go to the left, they choose an exercise that is very easy. Then on the axis, you see their level now. That is the green flag. Actually, I can show you this here. So their level that they have right now is indicated with this gray flag. And then if they choose a specific difficulty, the blue flag indicates the level that they would have if they solve an exercise correctly of this level. So obviously, if you make it very hard and you get that hard exercise correct, then your jump will be higher. I mean, you will increase your mastery level more, which makes sense. But by changing this slider and then seeing the effect on the visualization immediately, they could get like live updates, basically. And these are called what-if explanations. Basically, what will happen if I choose this difficulty? What will happen with my level? Again, we did a whole experiment here, but very briefly, having this visualization did not affect trust, which was surprising because that's not what we saw before. But what's interesting is that they chose harder exercises based on this exercise, on this visualization, sorry. So for example, here you see the difference between the groups with this, what-if explanation, this visualization here on the left, and the groups who only had control. So the groups who only had the slider, but not the visualization. And you see here, based on the difference of those two groups, you see that students typically chose harder exercises. That's this part on the complete right. And a little bit like higher on the middle, but definitely lower on the easy side. So this shows that having this visualization stimulated students to choose harder exercises instead of easier ones. What was especially interesting here was the whole design process. So I said to you already before, like it looks very simple, but actually there's a whole process going on. Maybe you've already experienced that yourself as well. Like making a visualization isn't that easy. It just looks very easy, but it's not. So I also want to show you a bit of these different iterations. This was the very first interface that we made with all the like recommendations in the exercise series, and then there would be a kind of like feature importance part. Also, our recommendations were based on how similar they were to the difficulty or the mastery level that they had. So we wanted to show that mastery level compared to the different difficulties of different exercises. And then we had this weird tree visualization. And then we had this what-if explanation. And we talked to both students and teachers. We made a simpler visualization where we just showed the mastery level and then all the exercises on an axis. And then, yeah, you see, for example, here that the exercises that are being recommended are yellow, and those are actually closest to the mastery level. So this just shows that the exercises that we pick from all the exercises that are available are the ones that are closest to the mastery level. So that's what we tried at least to visualize. Then there was this what-if explanation again that would show the changes in their mastery level. But that was still too complex. We showed it to students and they were like, we don't understand all these little dots. Like, what is going on here? So we had to like stylize it further and then even remove like this whole thing with the dots. That's why we ended up just with the what-if explanation, showed it again to students and teachers. And then finally we had our end results. So yeah, this is just to give you a bit of a glimpse of what happens in the background when we come up with this whole dashboard. You can do a lot more things, of course, and there's all these complex possibilities that we saw before in the healthcare domain or in the agri-food domain. But once you're designing these for students, very young children, then you have to make things a lot simpler. Then there's like a final example that I wanted to show. I'll actually do it a bit faster than I intended, but it's a nice bonus, I think, to show you what you can do if you make things a little bit more complex. So this is a bonus because it's not about explainable AI anymore, but it is still about education, but this time it's about adult students. It's people like you, basically. People like you, I'm not sure how it goes in China, but at least in Belgium, when you're following a master's, you have a lot of freedom in the program that you follow. So you can choose a lot of courses, and not everything is fixed. And this is very nice because it's very flexible. You have a lot of freedom, but it's also like pretty hard because there is so many courses, and then there's all these practical issues, right? Because courses happen at the same time, and then there's requisites, and then there's rules about you need X credits for a specific category of courses, and then there's all these limitations. So it's sometimes very hard to compose your program and see the connections between different courses. So I once did a project with fellow students on how can we support students actually with composing their program in a visual way and interact with a visualization and then compose their program afterwards. And this is the visualization that we produced. And I actually made a live demo of this because our system is still working. Maybe it's a bit slow here and there, but yeah, that's because D3 and all the algorithms that are necessary for this force-directed graph are sometimes a bit slow in the old version that we used. So you see all the courses and you see the different options that they have. So basically, there are 6 options that you can follow for your masters. The master's in computer science at KU Leuven. You can focus on distributed systems. You can focus on secure software, artificial intelligence, human-machine communication. And all these different options have like different courses that are attached to it. Some are optional, some are compulsory. So the ones that have this little circle here are compulsory, and the other ones are optional. And so the idea here was, okay, let's make an interface where we first show all the different options with all the different courses, and then they choose the ones that they like and don't like. For example, secure software. Oh, maybe internet infrastructure, that's not very interesting. Maybe this one, what is that? Capita, also not very interesting. So they can remove the courses that they don't like. And then they can pick a specific option that they do like. For example, human-machine communication, that is our favorite option. So let's go for that one. And then in the second part, they can compose their actual program after they give a bit of background information. So this is about my bachelor's, and then there's different requirements. And then here they could actually compose the program. So some courses are compulsory, some are optional, and then there's different requirements that they have to meet. So for example, let's maybe pick master's thesis. Yeah, they have to do that anyway in the second year. So once they choose it, then we can visualize the amount of credits that that course actually takes. And then we also visualize how these credits affect the different requirements that they need to fulfill. So, okay, let's add some more courses just to see what happens. For example, there's this course on foundations of human-machine interaction. We can choose it, and that's nice. But then you also see that that there are some other courses that are turning red, and that is because these courses happen at the same time. So you can't follow 2 courses at the same time, so therefore you have to choose. So for example, if we choose this one in our first master, let's say, then that's nice, but we cannot choose all these red courses anymore because they happen at the same time. And in that way, you can like continue composing your program. Sometimes you would see that if you highlight one course, also other courses are being highlighted here. Is because those are requirements. So for example, if you want to follow this course on computer graphics, the project, then we also first need to follow the theoretical course on computer graphics. Now we can do it in our second year, etc., etc. And so the little bulbs here, the gouges at the bottom here, show whether you have sufficient credits or whether you need more credits to fulfill the requirements of the program. So in that case, students could like visually compose their program, which was a lot more insightful and hopefully easier for them than doing everything by hand based on a long list of courses. So that was, yeah, the last part of this second class of visualizations that I wanted to show. And we again have some time for questions. So if there's something that you want to ask me, go ahead.
On this part? Yeah, it seems not, you know, so I think we can proceed. I think, yeah, we may only have 10 minutes at most, so I don't know whether you can. Yeah.
That's good. 10 minutes are fine. Actually, the last part, I can also talk for like 20 minutes or 30 minutes, but actually, I compressed it a little bit. What I wanted to do in this last part is to make things a bit more concrete for you. Because, yeah, maybe you're not going to be a visualization researcher. I'm also not like a full-on visualization researcher myself. But maybe you're not going to develop all these complex dashboards or maybe simple dashboards. What maybe you will be doing, depending on your job, is make visualizations that you can use in reports. And I'm pretty sure that many of you will still write reports in the rest of their lives. So in this last part, I wanted to show you some examples of my own reports and how I also integrate visualizations in them. So I'm not only researching visualizations, but I'm also just using them actually to communicate my results, which I think can be helpful for you to see. Obviously, this is just like some simple examples. I mean, this is not like the law or anything. It's just how I do things. And there's many more things that I could show, but I just made a selection of 5 lessons that I typically see others work that I do differently, where I think it can be useful for you as well to see how you can use visualizations to make your reports more powerful. The first lesson here is how can we make tables insightful? Very often people have like huge tables. This is a table from my own paper with the systematic review from healthcare. And then, you see all these different papers and then there's bullets and we classified them and there's like 200 bullets and it's not really like clear what the idea is. So let's zoom in a bit. Then you see that there's different papers and then every paper has different bullets for different categories. But it's like, what is the overall message here? I mean, there's just like 200 bullets. So what is the idea? So what people then very often do is, oh, we'll just add like a total line at the end. And then we'll just say how many bullets are in this column. It's like, okay, cool. And that way, at least you get an understanding of, for example, activity. The activity of interpretation is more present than prediction. Great. But still, there's a lot of numbers. And, when you look from a distance in this table, it's still not clear, right? You just still don't see the patterns. So here's a very simple trick. I just add a little bar chart at the bottom, a bar chart of those numbers. And now if you look from a distance, you don't even have to see all these different bullets. You don't have to see all the papers. You just immediately can see based on the bar charts that, for example, interpretation is a lot more present than prediction. Very nice. Maybe you could have seen that if you look at the 2 first columns. But then if you go and check out the third part about interaction, for example, it already becomes a lot harder because there's bullets everywhere and it's not clear what is a lot, what is not a lot, because everything starts to like mingle in your mind. But if you add the bar chart, then you immediately see, oh, actually encode and explore it's not being supported very often, but select is being supported very often. So a very simple trick to make a table more insightful. Here's another example of the agriculture thing, the thing with the fan charts and the interviews that I did. You see the different participants, those are the columns, and you also see different things that they said. For example, the pass fit and the uncertainty are not understood by participant 7 and participant 2. Okay, and all these other participants in the bottom row, you see that they gradually improve their mental model with the visual components. Okay, great, that's nice. But so how is this insightful? It's not very insightful. You just know that participant 3 understood it and participant 2 did not understand it. But you also see that I kind of ordered the participants in a specific way. It's not participant 1, participant 2, participant 3, because actually what I did is I ordered them according to the mastery or their experience with predictive regression. So here you see 2 things immediately. You see the distribution of how experienced the participants were with prediction regression. That is shown on this line here. And so you see, oh, participant 7 and participant 2 had a low experience, and all the others had very high experience. And then when you combine that with the table, that makes it a lot more insightful, because now you see that, oh, actually it's people with low experience. They did not understand the pass fit and the uncertainty. And that makes a lot of sense, right? Because if you don't have experience with predictive regression, then past fit and uncertainty, those are concepts that you're not very familiar with. Whereas if you are very experienced, then you do know these things, and then you understand better how this model was behaving. And so this also explains why all the other participants had a better mental model. They understood the model better. So adding a different visualization or ordering your table in a different way makes it a lot more insightful. The second example or the second lesson is use colors consistently. We know this from visualizations, where red always means the same thing. It's a kind of category or it's a warning. And we would use red always for the same kind of thing. But very often people forget that when they write a report. So here is a paper of mine. And on the second page, you immediately see that I highlighted 4 words: usability, usefulness, needs, model, understanding, and trusts. And I gave them a specific color. And maybe you even remember from before that you saw these colors before. Actually, when you check out the rest of the paper from a distance, you see that I use the same colors throughout the text. Sometimes I highlighted words. Then sometimes there was this text box. There was this table even. And the text boxes would, in purple, would all be about usefulness needs. The one in orange would be about understanding. The ones in blue would be about trust. So by using the 4 colors consistently, even in figures, as you saw, these are the figures, 4 same colors, the 4 same categories. It's very easy for readers to find the information that they are looking for. If they're looking for information about usefulness and needs, they will just skim the whole text and look for purple. And then they immediately find that information, which is, I think, very insightful. Here is another example of the paper with the slider and the visualization on the educational dashboards. There were 3 groups, as I told you, and I gave each group a specific color. So the group with the slider control and the visualization, the impact of the control, that was always green. The ones with control were always orange, and the ones that didn't see anything were always blue. And I used these colors in the first figure when we were introducing the participants. And we were using the same colors in all other visualizations in the paper as well. So in our report, we had, for example, these box plots, and then they had the same colors. And we also had this line chart that was showing like the changes in mastery of all the students in the different groups. And actually, the only thing that was interesting here is what is the average of the groups and how did it differ? And then you immediately see, oh, green, that means control and impact. Oh, they performed higher. Okay, interesting. So by using these colors consistently, you get the insights a lot faster. The third lesson is suppress less important information. And again, I want to show you the first example of a table. Very often people just put like 500 numbers in a table and then expect a reader to understand it and get the insights. That's not how it works. And we know that from visualizations. So what I typically do in tables is I just suppress the information that is less important. For example, let's say you report your statistical findings. Some of your findings are statistically significant and some are not. And in this case, for example, non-significant results were not important for my story. Maybe they are in your story, but in this story, they weren't. And therefore, I grade them out. They were less important. The data is still there. You can still read everything. But you immediately, visually, you understand that the black information is the important information. Those were the significant findings. Same in visualization as well. All the changes in the mastery of a specific student in a specific group, those were not the important things. That wasn't the message. The message was what happened in the groups on average. So I showed like all the different lines in this spaghetti plot. I grayed them out and I just highlighted the average change with the groups. Here's another example, also something that you would very often see, like you have a lot of correlations, and probably you can guess here where I suppress the less important information, because you see that, yeah, indeed, there's some of these boxes that were white. These boxes were not significant correlations because the correlations were very low, like minus 0.01. That doesn't mean anything. So you can show that it doesn't mean anything by graying it out. And that is kind of the message, right? The exact number doesn't matter, whether it's 0.05 or 0.01, doesn't matter. The only thing that you want to communicate is there wasn't an important, significant correlation here. But lesson 4 also tries to warn you a little bit. It doesn't mean that if you suppress data that you therefore have to forget everything. Sometimes you actually want to show the actual data that you have. And this is also something that maybe you will do when you do a human-centered research with a questionnaire. Typically, you ask questions, and then you want to report the results, like the answers that people gave. And that's great, but typically what people then do is, oh, X% of the people said this, answered this on question 15, for example, and then that's it. But actually, what is very insightful is show the distribution of the answers, because in that way you get a lot more insights in whether people agreed or did not agree. So for example, in this visualization, this is called divergent bar charts. You just show all the different categories and the percentage of the answers, which is a lot more insightful actually than just saying 15% of students agreed with this question. You see the complete question, you see the complete answers. Same with the visualization that you saw in one of the previous slides. Just showing box plots is very hard to interpret, and it's not always as insightful because you don't really see the data. So there's a whole blog post written by someone else that I put here in the link. But what I typically do is I just overplot the box plots with the actual data, such that you can see the actual data points, you can see the distribution, and it's not just like the average answer, because an average of 5, it's not very insightful, because I don't know, does everyone say 5, or is there like a big inconsistency maybe in what people are saying? And then the final lesson is also enrich your visualizations in a meaningful way. So here's a line chart that I once made, and you see that the first thing I did is instead of just adding the legends next to the visualization, that would be a bit hard, because then, you know, participant 1, 2, 3, 4, 5 would all be mixed up in the visualization. So for example, if you'd be looking for participant 4, red, then you would always have to map like, oh, 4 means red, and then I will go to the line chart and I look for the red line. That is not very easy to do. So what I did is, instead of just adding the default legends, I reordered everything according to the order that you see at the end. And so now you immediately see, oh, P4 is the red line, P9 is this green line, etc. So a lot easier. You can go one step further. Maybe you remember from the study that there was a part where we only showed one country, and then there was a part where we showed 2 countries. And you can also show that here. So scenario 1, 2, 3, 4 correspond to 1 country. 5, 6, 7, 8 correspond to 2 countries. And you immediately see that. You don't need the story, you just see it in the visualization. So that's nice. And then the final step here is give a little bit of background about the participants as well in this visualization. So high means the high experience with predictive modeling, and a medium and low experience. And so this shows, for example, that if you look at this trust scores, what's interesting is that people with high experience can both trust it very much, but also have a very low trust, because you see highs both at the top and at the bottom. So by having like these extra layers of enrichment, you make your visualizations a lot more insightful. And that was it for the third part. And basically, I think I can finish here and then ask some questions at the end. Just wanted to show you the reference to my website again, in case you found this interesting and inspiring. I regularly update my website with the research that I'm doing, and there's a lot more like blog posts and everything. So I will write a blog post, for example, about the 5 lessons that I just showed you. And with that, thank you very much. I hope you found it a bit insightful, inspiring to see how I use visualizations, both in my research and in the research practices that I do when I report my findings. And hopefully you can use all those takeaways and all these examples to make even better visualizations yourself, and really inspire the next generation of researchers and data analysts, basically, to use visualizations more effectively. Thank you very much. And if you have any questions left, then feel free to ask them now.
Thank you, Professor Yaron.